this lake. When we check the lake over time, it becomes obvious that there is a large increase in this lake level, and this is the situation of the Glof in 2014, and we could also detect from older satellite imagery that there were some fluctuations of the lake level in earlier times, and that was confirmed indirectly by the local population, by villagers in Gowhar town, who reported that some 30 years ago there was a small flood without rain that damaged some fields, and this small flood without rains that might be the same case as in 2014, that the moraine, that the ice-cored moraine was thawing, and that there was a piping process, and this may reoccur more often due to permafrost thaw of this ice-covered moraine. And when you go there in 23, you still see the remnants of the ruined houses demolished from this flood in 2014. And what can be learned from this situation? Of course, we have to concentrate on the cryospheric hazards that come together with the cryosphere changes, not only glacial lake outburst floods, but also glacier detachment, as you have experienced here in Uttarakhand in the Chamoli event. But we also have to think about how are the interactions with the adaptation strategies and with the governance structures. And coming back to the area of Gowhar, the land use system has changed, whereas in the older days there was a regular transhuman system that the people with their animals went in large numbers to the high pastures. This has been reduced to only a few people, a few families, a few households who bring their animals to the upper parts, so that the awareness of the presence of this glacial lake has been reduced. And immediately after the Glof in 2014, people were building try to stabilizing the river banks with these concrete measures. But as this photograph from 2019 shows, this has already been destroyed again. And moreover, the bridge that was destroyed in 2014 has been rebuilt on the same spot. That might be a problem for future Glofs that will almost certainly happen sooner or later. So coming to the conclusions, I think there's an increasing probability of cryosphere hazards, and what is really required is that local disaster awareness and preparedness campaigns, together with efficient and reliable early warning systems, have to be carried out. And in this, we need the integration of local environmental knowledge and their experience, their lived experience. They give more insights into the situation than only the instrumentation with high technology. The technological monitoring measures are necessary, there's no doubt about that. Installations of sensors and ideally also fixed cameras that can transmit the situation on the ground, and they should be combined with site-specific land use planning and adequate adaptation strategies. And this also includes settlement planning, leaving the main channel that will be reused in the next Glof that will happen. It means learning from disasters, and it means also managing the unavoidable, because the next Glof will almost certainly happen, and you cannot avoid all these problems that come with the increases of lakes. Siphoning of all lakes is simply impossible. You can maybe siphon one or two lakes, but others will not be there are simply too many. What about the urbanization process and new infrastructure development? They generally increase the potential of loss and damage from floods. And even small gloughs can be potentially harmful for local livelihoods, as in the example of Ladakh. They may destroy the entry points for the irrigation channels. They may destroy part of the irrigation network. So this are definitely problem. And glacial lake inventories should be ideally combined with detailed socioeconomic surveys, so that in the context of socio-hydrological studies. And that's, thank you. With this, I would like to thank you for your attention.
Thank you, Professor Nasser. I think you have clearly highlighted the risk associated with our cryosphere, with the melting of glaciers, glacier lakes, and the potential for glacier lake outburst floods. Now, across the Hindu Kush Himalayas, we have something like 54,000 glaciers, estimated 54,000 glaciers. Now, many of them are melting very fast, and the glacier lakes are expanding, and the risk from gulf is increasing. So I think this really illustrates the danger that we face, the mountain communities face, and the need for taking into account upstream, downstream linkages. So disasters are transboundary in nature, so we need to have very good communication, information exchange between upstream and downstream communities. Thank you very much. Now, I would like to hand over to my co-chair to invite our next distinguished speaker, distinguished panelist.
Thank you very much. Now, may I request Professor Onkar Singh ji, just to say about this resilience, what we can do for the sustainable development, what we can do. And Professor Onkar Singh is the Vice Chancellor of VMSP Uttarakhand Technical University in Dehradun. Professor Singh, sir, you can deliberate upon. Singh is there? Oh, okay. So we'll go to the next speaker. I'm very happy to have Professor S Rawat ji. He is an emeritus scientist at UCOST. He will be deliberating upon this important discussion, what we are having today morning.
Respected Member of Parliament, Sri Munna Singh Chauhanji, session chair, co-chair, panelists, and distinguished participants. I'm very happy to give a few thoughts related to disaster resilience and sustainable development in the Himalayan region. Professor Nusser has very nicely presented a case study of GLOF in Ladakh. And not only Ladakh, but entire western and eastern Himalayan region is very, very vulnerable to GLOF, we all know. And he has also highlighted what way we need to plan our infrastructure, what kind of considerations are there. So I'll not touch into that, but I would simply draw attention of the House on only three issues. One is a need for more investment in research and development as regards to disaster risk resilience and climate adaptation. Second, adopting nature-based solutions to go for disaster risk resilience. And third point I would like to make is integration of traditional knowledge with the modern science. Talking about the first point, research and development, it is a reality that the disaster risk resilience and climate resilience is still in a very nascent stage in the Himalayan region. Despite several programs and long-term projects, local communities, especially the mountain farmers and herders in the remote areas, are still very vulnerable to extreme weather events like flash floods or the hailstorms or the drought or sometimes flash floods and cloudbursts and so on. And our ability to foresee such events, despite the modern tools and the technologies, like we are talking about artificial intelligence, machine learning, and so many tools and technologies, our ability to predict simple things like cloudbursts is very limited. And this throws a big challenge, even though there are broad patterns based on research. Of course, Government of India and Uttarakhand government and all state governments in the Himalayan region have established their disaster mitigation cells and the climate change cells in the states. But I see, a lot needs to be done in terms of involving the citizen science and the local communities in collecting long-term data. In fact, the number of weather stations in the Himalayan region is still below the, desired level. There are, in many areas, there are definite gaps in the climate stations. And we do not have long-term data so that we can model, predict such events. So such things, I would like to say that when we come to, establishing center of excellence in the climate research or the disaster resilience, of course, government of Uttarakhand is very much, it has recommended, as indicated by Honorable Chief Minister during the inaugural session. He has indicated establishment of such a center of excellence for the Himalayan region in the state of Uttarakhand. That such a center would certainly need a very, very integrated approach, and also it will require expertise from all over the world so that we fast forward the disaster mitigation and early warning systems have to be developed. So that is one important point I would like to make. Now, second point I would like to highlight is the need for nature-based solutions to climate resilience. All over the world, different international and national agencies have time and again stressed the need for emphasizing the role of nature-based solutions, not only for biodiversity conservation, also for climate change mitigation and adaptation. And as our session chair in the beginning said that, the adaptation to change, not only for restoring the natural ecosystems, but also meeting the needs for present as well as future generations will be very, very important. We know that Himalayan ecosystems are degrading very, very rapidly. I remember one famous astronaut a few years ago. He had traveled across the Himalaya from the, from the space. He says that over 30-40 years, the Himalayan region has become more dusty, smoky, and a lot of aerosol has deposited. As a result, it is bound to have faster glacial melt as well as a lot of disasters. So what are we going to do to, restore such ecosystems? And we know that restoring these ecosystems as well as avoiding desertification, avoiding forest fires, and also and also going for green economy, green roads and green infrastructure, green industries are the part of nature-based solutions. We need to think very hard on those issues, and we need to involve local communities in implementing these plans which are based on nature-based solutions. And lastly, I would like to underline the need for integrating traditional wisdom and capacity of rural mountain communities with the modern science for disaster risk resilience and climate resilience. Dr. Mark Nusser also had also pointed out that local knowledge and their ability to cope up with such things is very, very important. Quite often we assume, I'll just take 2 minutes. Quite often we assume that local people do not know much, and it is we, city-bound people who have studied a lot of theory related to disaster and so on, we will be able to teach the local communities how to mitigate and how to adapt, for the coping with the disasters. But we know there are hundreds of examples in the Himalayan region where the local knowledge, local communities, wisdom, and the age-old wisdoms have come in the rescue of such disasters. If you take for example, flood areas or the glacial areas or hailstorm areas, But of course, with the modern tools and the technology, if we integrate the local knowledge as well as the modern science, we can do faster, resilience recovery, as well as we can possibly, learn from the local people. And lastly, I would say that in all these areas I have spoken here, innovation, collaboration, and communication, three things which are the pillars of this present Congress, they will become handy in every case. And with this, I will stop here and thank the chair for giving me this opportunity. Thank you all.
Thank you, Professor Rawat, for giving a nice overview on this aspect. Now, may I request Dr. Deepak Malik ji, our DRM specialist, World Bank representative.
I have 5 minutes, yes. Distinguished guest, Dr. Chauhan, Dr. Prema, Dr. Singh, Dr. Kumar, all the panelists, ladies and gentlemen, very good morning to all of you. I'm privileged to be here to be able to speak on sustainable development and resilience in Himalayas. As representing the World Bank, I think the first and foremost thing for all of us, whether in India or in other institutions, we all work for the development. We are here to eliminate poverty and boost prosperity in a livable world. And that is, when we talk about livable world, we are talking about resilience. We are talking about ensuring that we ensure that zero carbon, net carbon becomes a reality one day. But before I go into details, I think I would first like to congratulate Government of India, Government of Uttarakhand and other states in the way we have started managing disasters. In last 20 years, we have seen a big transition from the time when we started looking at the disasters. And I remember that we have now NDMA, we have now National Institute of Disaster Management, we have the SDMAs also now, and we have Institute of Disaster Management, one is national, and then now the regionals are coming up. We are also going to see a very big one, Himalayan Institute of Disaster Management very soon, about which our Honorable Chief Minister also talked about. NDRF, SDRFs, and there is a lot more to talk about what we have seen in the last 2 or 3 decades in terms of disaster management. And there is a clear visible result out of it, which we have seen. There was a super cyclone in Odisha in 1990s, and the level of casualties at that time, and recently when cyclone happened in Odisha, the stark difference between the number of casualties which have happened, we can proudly say that we have come a long way, and we now see much lesser casualties than before. So bravo to all of us. But having said that, I would like to say that yes, we have still a long way to go, and there are few good pilots which in India we have done and which requires replication and also put to use. For example, there is a recent State Disaster Rescue Force training campus which has come up in Uttarakhand, and there is a big possibility for use of that institution for trainings all across. Then there are examples like mathematical flood warning models which was developed in Bihar. So yes, I think such examples, such pilots require replication. And there are areas which still require some more work. For example, what Dr. Rawat was talking about, the meteorological network, which is yet to be expanded, which is not yet providing the required location-based information which is required for early warning for, and also there is a lot of work which requires an early warning dissemination. And also I think there is a big scope for working on making the key infrastructure seismic proof. And for example, if we look at our infrastructure, whether it is, thank you so much, whether it is in Uttarakhand or any other places in seismic regions, I think we are yet to understand how safe we are, how bad or how good we are in. And in Uttarakhand, we had the opportunity to work with the government of Uttarakhand, where I think this is a very good example where they have an inventory of 18,000 buildings for which DVA and RVA were done, and they know where they stand in terms of their key infrastructure. Similarly, I think there is still a big need for working on risk financial systems. With that, I would like to conclude that yes, sustainable development cannot be achieved without resilience, and we stand along with the Government of India and Government of Uttarakhand to work towards it. Thank you so much.
Thank you, Malikji, for deliberating upon what we have done to reduce the disaster and what are the challenges ahead and how we will be able to do that. So now next go to Dr. Gowhar Meraj. He is the JSPS postdoctoral fellow from University of Japan. And yeah, he's there right now.
Respected Member of Parliament, Shri Dr. Mona Singh Chauhanji, Chair of the session, Co-Chair of the session, and other dignitaries on the dais. Thank you very much, and good morning to all of you. Basically, I'm an Indian, proud Indian. Before moving to Japan, I was working as a scientist here. So I thought it is better to just set a forum here to share my experiences as a researcher being in India and a researcher being in Japan. So this whole idea, because Professor Nusser has already given us some idea how as a researcher we do research and how intricacies there are involved and how deep we go and then how we come up with the final results. So I will be just giving you an idea what we have done so far when I was here and still I'm doing there, and what are some gaps we can fill in, and in which government of our worthy government has to help us a lot, and so that, because resilience and adaptability is the final. Our research is only valuable when it is being implemented at the ground. That is the most important part. We do any research, but if it is not implemented and the common people are not being helped by it, our research, then I think the research is not serving its purpose. So this is the problem we are facing right now in Himalayas. We saw the GLOF, we saw the in Shimla landslides. I am showing here a picture of the Delhi floods because I have a story for it next in some slides. So briefly, I will be discussing my own experiences in working in this field, and now what I have seen in my lab, and then what are the summary and how we can use the ecosystem services for helping us to solve the disasters. So basically, if I sum up the disaster management, I know there are many actors and many players doing a lot of roles, but just to make it very simple, there are researchers and there are the policymakers. Researchers try to know what is the problem and try to provide solutions, and finally, the most important are the policymakers who have to implement it. So as far as the research is concerned, I was part of a research in Kashmir Valley where we located some of the dam sites. We know in 2014 there was a massive flood in in Kashmir. So I was associated in a research where we located some of the dams. If they could have been there, this much of volume would have been stored, and it could have led us to have a very basin lag time would have increased, and it would have given us some early warning management strategy at the end. I was also part of a research which we done on the national highway from Jammu Srinagar, where we just made a landslide early warning system, and we found that ambient soil moisture is a very important parameter. If we have the real-time ambient soil moisture data available at certain locations, we can forecast the landslides using some machine learning tools. And I'm also associated with the Brahmaputra Basin, where we mapped the whole area of the Brahmaputra Basin, whole Brahmaputra Basin, and provided flood susceptibility mapping using a lot of machine learning tools, and then we did some ensemble. And I'm not going into the technical details, I'm just giving you an overview that as a researcher, how much we do. That is the question. That is and regarding the Delhi floods, although it does not come maybe directly related, but I was associated with the work where we found that the recurring Delhi floods is basically one of the main causes of it is the increased imperviousness of the landscape. That is causing the Delhi floods. This has a story with Japan. I'm just going to that. So all this work, everybody is doing research, and finally, does this find the takers? That is the most important thing. And what I showed, I know there are lot of people doing the same research, and there are redundancy also. There's a redundancy. I'm doing the same work, that is doing the same work, everybody is doing the same work. For a policymaker, it's very difficult to understand whose work to take. Yes, 1 minute, I will just... So as a policy maker, he has to finalize and implement it. Just to make my point, I just want to give you my experience of my lab in Japan. My lab is directly associated with government of Japan and Department of Agriculture. They have an issue of land abandonment, and they told my professor, let us solve this issue. We came up with similar professors, and we provided this solution to the government, and they implemented. Just simple, streamlined, focused work. Tokyo is the largest city in the world. It has the population which has the whole Canada. Canada population, it is said that Canada has the same population which only the Tokyo has. But if you will see the stormwater drainage system and how they manage the stormwater, it is amazing to see. This solution, if you will see, my hydrology people will know that they have different type of macadamias available on the roads, and porous infiltration, which infiltrates, our water infiltrates over that. So this is a solution provided by the scientists. So we have a huge workforce available in our country as a research institute. So cannot we use this workforce for finding solutions together? This is the most important. Streamlining their efforts and reduce the redundancy. We already have less amount of GDP available for research, only 6.65%, while in Japan it is 3.65%. So we have least resources, financial resources. I know we have other important works to do, but can't we use an efficient system to streamline the research and reduce the redundancy? So the need is government must entangle the rigorous mechanisms and provide solutions at a fast pace. Just to give you an example, I'm very sorry to say, I needed 1 million instrument in my lab. I asked my professor, on the third day it was on my table. Because they have a lab which has a credit card. They bought the equipment from the credit card, very simple. So this is how the things can be. If we want really on-ground solution, we have to give power to the researcher. We have to provide powers to the researcher. I really congratulate Professor Durga Pantji, who said that we will be having a National Institute for Disaster Management in the Himalayas for a Himalayan course. Because that very institution can serve as a bridge between the researchers and the policymakers. It can provide the solutions and taking the researchers.
Professor Meraj,
yes, sir. I will continue. I will finalize. So as a researcher, I need to provide decision makers an option that why you are doing this and why you should not do. For that, ecosystem-based disaster risk reduction is very important, as our worthy guest already told you. In Kashmir, we already did this thing, and if anybody has any questions, I can then, in summary, policy-oriented research in disaster management through a bottom-up approach is needed at the moment. We must strengthen and channelize energies and expertise of the huge workforce we have at the research institutions in our country. We can use case studies from other parts of the world to help us deal with the issues. Lastly, but I will end with this, climate change is rapid. Our adaptation and resilience building must be rapid. In this, our government has huge responsibility on its shoulders. Thank you very much. These are some of the people who were associated with all of the works I showed. And in Japanese, we say arigatou gozaimasu. Thank you so much.
Thank you very much, Dr. Meraj. I think you have given a very interesting perspective on the need for focused research and the importance of research in decision making and implementation. Now, I would like to invite Professor Ashish Pandey, the head of Department of Water Resources Development and Management, IIT Roorkee. Is Professor Pandey here? No. Okay, then we can go to the next panelist, Dr. Paramesh Banerjee, the Director of Prayuki Geomatics from Singapore.
Thank you very much, ladies and gentlemen, and the panelists, the guests, particularly Mr. Chauhan. I am really glad to see a political leader taking so much interest in disaster management. And last day I heard his talk in Wadia Institute. He's quite knowledgeable. So this is encouraging to the scientific community. I'll come right to the point because we are not having much time now. I actually belong to Dehradun. And when I started my career as a scientist at Wadia Institute of Himalayan Geology, the first thing I realized is we don't have data. I am a geophysicist. We are working on earthquake and the formation of Himalaya, tectonics, everything. So then we started generating data, but that was on an individual basis funded by Department of Science and Technology. And after that, I went to different other places, other universities, and set up scientific infrastructure in different countries, which leads to disaster management in earthquakes. So I'm a hardcore experimental people, instrumentation person. So I'll come directly to the point. So how do you go to the next slide? Okay, so the Himalaya is facing with two types of disaster originated from tectonics, which leads to earthquake, and another is global warming. And landslide is actually a mix of both. So out of this tectonics, we cannot control. It will keep on happening. We can only manage it, mitigate the effects. Global warming is, in a sense, is inevitable. It is a cycle. It keeps on working. But the problem now is we are accelerating the global warming. So we can try to reduce it. So we can manage global warming right at the source, whereas tectonic we have to manage towards the end, okay, just before and after the disaster happens. Right, so one slide on understanding tectonics. I think you all know about that Himalaya is basically a very dynamic system. So the India plate is moving towards north at nearly 4 centimeters per year. So this is what we did when I was in Wadia Institute. We put permanent GPS stations and measured the motion of the India and then several other places in Asia. And we found that India plate motion is 4 centimeters per year towards Eurasia, and that 4 centimeters is being consumed in Tibet and Himalaya. Out of that, Himalaya contributes to 2 centimeters per year. So the meaning of this is illustrated by a very simple fact. If you take the place from Mohand up to Uttarkashi, and you place a scale or something like that at the two ends fixed to the ground, with the time, automatically it will deform because this is shortening. So this is we call shortening. And because of deforming, the length is decreasing, which can be measured by GPS, and at a certain time it will break. When it loses the strength of the material, this is earthquake. Okay? And this earthquake cyclicity it has been found around 500 to 700 years. Now, what we have seen from different studies, that entire part of the Himalaya has to break like that through earthquake and adjusting it to the process. But the region between Dehradun and Kathmandu has not broken or has not experienced a big earthquake in last 500 years. And we know how much shortening is taking place. It is continuous process. So almost 10 meters of shortening has taken place, and this earthquake has to happen. That's why we keep on saying that this place is vulnerable to a big earthquake, more than 8 or so. Nobody knows when, but it is inevitable. It is going to happen. So this is coming right from the instrumental measurement, direct measurement, and there is no doubt about it. But we need more instruments. The second thing is the global warming. Now, I'm very glad to have the DG of ICMOD here. Actually, I now live in Kathmandu, and we are within 3-kilometer distance, and I never met him. So very glad to see you. Now, ICMOD is doing an excellent work in climate research. Not much on tectonics, but on climate, they are the top, and we are very glad to have them. Now, their prediction is, with the Paris Agreement, if we can achieve a 1.5 degrees centigrade of warming, 1/3 of the Himalayan glacier will vanish within next 80 years. And 1.5 centigrade is not being achieved. It is realistically, it will be 2 or maybe even more, then 2/3 of the glacier will vanish. Now, these glaciers are feeding the Himalayan river system. You see, the Indus, Ganges, Brahmaputra together is being fed by these glacier rivers, which is coming through water, and nearly 1 billion people's livelihood depends on that. Okay, this is a food basket of not only India, but entire Asia and some part of the world also. So this deglaciation is very important, and if we lose even 50% of this water within next 30, 40, 50 years, this is a disaster on the making. We all know that. But the point is what we are going to do to manage it. So I have only 1 minute left for me. Okay, so I have 2 solutions. One is the mechanism to develop the infrastructure. See, this earthquake, all these things need data, the field data. We are lacking this thing. We need a systematic data collection mechanism which government can fund. It can be corporatized also, but it has to be a separate observatory type of thing, which many countries have already done. We will set up hundreds of GPS stations, seismic, thousands actually. And then for global warming, to retain the water, instead of flowing it to the sea, try to retain it as much as possible through reservoirs and dams, etc. So we have the problem, what we know, the knowledge requires the data, for which we need to take an immediate step of setting up a dedicated center for data collection. This is not the job of research institute. The scientist cannot do it. Okay? This data collection needs a professional, dedicated team, and this data can go to the research institute, and then they churn it out and come out with the solutions. I'd like to mention that Japan has more than 2,000 permanent GPS and seismic stations, whereas in entire Himalaya, we don't have more than 100. Okay, this is the gap what we are facing now. Another thing is that Himalaya is the topography-based thing, and we do not know the topography. We don't have a good digital elevation model. So now the technology has come, airborne LiDAR. Okay. Nepal has taken a step. Actually, we initiated it, and they have decided to cover entire Nepal with airborne LiDAR. We just completed a 20,000 square kilometer LiDAR. It gives a high resolution, high accuracy topographic map. We call it digital elevation model. So this is needed for the Himalaya, entire Himalaya, at least the Indian part of the Himalaya. So this is what is required, the topographic base map, instrumental monitoring, which will include GNSS, seismic, weather stations, airborne survey of all types, and early warning system we all talk about. Please know that without these 2 things on top, early warning system cannot work. Okay? Early warning system is very instrumental thing. It needs all this infrastructure plus a very good telemetry. This is another challenge. And these are the job of the professional. This has to be given to somebody who can manage a team, an institute, an observatory type of things. So this is details about what Himalayan Observatory can do. We don't have time for that. And improving water infrastructure, I mentioned that we only use only 10% of the water resources for generating electricity. So this can be tapped in. And making dams, multiple dams and reservoir can improve the flood mitigation and store the water so that it is not wasted, and also improve navigation and other things. And this shows how this is actually taken from ICMOD report, how the glaciers are feeding most of the water resources in river system in India. So one last slide. This shows a correlation between the GDP of a country and the loss from the hazard. This I made for earthquake only, but this can be for everything. It shows that if a same magnitude earthquake occurs in different countries like America, Japan, India, Nepal, China, the loss is proportional to the GDP, or inversely proportional to the GDP. The more GDP you have, the less is the loss. Why? It is not for money, because the government has put more money in developing scientific infrastructure. So that is the point. Okay? So even if we have less GDP, the government willingness can increase the component of that income to scientific infrastructure development. So this is the final word. Two things, if we can do from this conference, one is initiate a data generation process, institutize it so that it can be done in a proper way, so it can feed all the researches. And second is develop a task force for immediate implementation of better management of water resources. So these two things I think is very important and urgent to take up. Thank you very much.
Thank you very much, Professor Banerjee. I think you have clearly highlighted the risk that we are facing from the tectonic shift in the form of earthquake. I think the recent earthquake in Western Nepal is a typical example and a warning for all of us. And then also the impacts of global warming and the rapid melting of glaciers. And I would also like to acknowledge that ICMOD has been working very closely with the Wadia Institute of Himalayan Geology. And we also look forward to working in the coming years, working more closely with you. I have with me our chief scientist for climate, Dr. Arun Shastra. So I hope that there would be opportunity to discuss with the institute and other partners here. Thank you for highlighting also the solutions. You have not just mentioned the risk, but also came up with some solutions and some concrete recommendations, and I hope that we can take this forward. Now we have the distinct honor of inviting the Honorable MLA, Dr. Muna Chavan Singh, to share his thoughts. The political leadership, as I mentioned earlier, is very, very important. We can generate a lot of data, a lot of science, a lot of evidence, but if the political leadership doesn't support, then as already mentioned, they will not be able to implement. So, sir, you have the floor. Yeah, you can speak from here or from here. That's great.
Good morning to you all. On the dais, Chair Dr. Phema Gwatso, Dr. Navneet, Dr. Maracos, Dr. Banerjee, Dr. Gowhar Meraj, Dr. Deepak, Dr. Singh, Dr. Rawat, distinguished scientists, geologists, researchers, and officers in uniform, those who respond to the disaster mitigation, rescue, rehabilitation at the first call on ground zero, and my dear students. 3 days back on 26, when Professor Durgesh Pant invited me to pre-Congress deliberation, I was a little lost to understand what does it mean to me. And I was wondering, lest I speak some absurd things on such an august gathering. But since I'm used to speak extempore, even if I try, I can't read out a written text. So somehow I gathered courage to speak from the dais on the subject of disaster resilience and risk reduction, etc., etc. Today I'm amazed to see Dr. Fema. Large number of the speakers from the dais, they address the very same concern which I highlighted that day. What was in the center of my thought? Research, technological advancement is of no use if it is not actionable, if it cannot be implemented, if it is not adaptable. Dr. Fema, Dr. Navneet, in other words, as a political leader or as an elected servant of the society or as a part of the government or as a part of the instrument responsible for implementing any legal framework as a legislator, the immediate challenge that we face is how to implement the recommendations. Sometimes such deliberations end up, making hyper-scientific super engineering, as I said that day, which is far beyond the reach of the common man. And probably Dr. Gowhar highlighted, if it cannot be implemented, it is good for nothing. But I'm happy to note that large number of these distinguished experts are thinking on the similar line. Recently, at the G20 leaders meet in Delhi, it achieved many milestones. It unanimously evolved a 83 paragraph resolution, and disaster resilience and disaster risk reduction has clearly been mentioned at para number 46. Not only this, the G20, New Delhi G20 Leaders Declaration and the G20 meetings in the Indian presidency, that is the Prime Minister of India, has reflected complete commitment, total commitment for accelerating the complete implementation of Sendai Declaration on DRR. When we talk of accelerating the implementation of Sendai framework on DRR, that means this needs to be correlated, collaborated. That is why at the global level, CDRI has come up and multilateral approaches and close collaboration among the world community, global governments are required. Secondly, when I was speaking to my friend, Professor Durgesh, what has been most, compelling, you might not have seen a politician of my kind, who is such a useless politician, who is not prepared to leave the dais. Otherwise, the politicians are normally in tearing hurry to go off. But I'm such a useless person that I remained stick to the dice for such a long time. Region, for simple reason, see, when we talk of the sustainable development, sustainable development cannot be thought of without the infusion of technology, modern science, and traditional knowledge. The indigenous knowledge. Marcos, Dr. Marcos, probably I commented the same way that day or two. I'm not averse to using the modern technology, the modern scientific knowledge. But to write off the traditional knowledge, to write off the indigenous knowledge, will also lead to disastrous consequences. I always say, over the centuries, people have learned to live with the disasters, especially in the Himalayan region. I'm the resident of this Himalayan region. We witness landslides, flooding, ice breaking, glacier breaking, although not my cup of tea, discussing the science of glaciology, hydrology, geology is not my cup of tea. I'm no expert in the field. But let me give you one example. I come from a remote mountain village. What kind of a farming pattern people in the hill areas follow? They cut the terraces, make the benches, do the farming cultivation, green the slopes. Now I can ask the scientific community, is it not trench cutting? Is not terrace making? Scientifically and structurally, slope stabilization process? It is. Because it cut down the runoff conditions of the water. As the slope increases, the water that comes down gusses with more and more speed because of the gravity, as we all understand. So by cutting the terraces, they have been reducing the slopes and reducing the water runoff conditions. So this needs to be encouraged. This needs to be built into the planning process. I don't remember exactly the name, Dr. Pema. Someone from the dais mentioned that land use should be precisely as per the terrain. Land use should be precisely as per the terrain. Therefore, because the core to today's that in fact attracted me, that allured me to come and sit here for a longer time was the sustainable development. Sometimes what happens is, people talk lopsided. They'll either talk of the environment protection, completely ignoring the livelihood of the people, or they talk of the material development, completely ignoring the environment, geology, and hydrology, and risk of disaster. I believe both are not practically possible. We are the native of the Himalaya. We have to live here. We can't run away. We cannot migrate altogether. The best way is to live with it. How to live with it is a matter of concern for all of you. Therefore, I think the time has come. Even we talk about the IHR, Indian Himalayan region, and so is the case with the rest part of the world. See, disaster is not just earthquake or flooding. Forest fire is another menace. Depleting water sources is a future disaster. If you go to the deep forest areas, water sources are fast depleting. How to ensure the recharging of the water resources? Because if the water resources and the gravity is not available, it is not possible to live in the mountain area. It is simply not possible to pump water everywhere, every nook and corner from the downstreams. So gravitational flow, the gravity source of water, Dr. Singh, because Himalayan Institute, World Institute of Himalayan Geology is a home to, all such experiences. So this needs to be done. I have always been talking even in the legislature also. Dr. Pena, Dr. Navneet, I have been talking even in the legislature. There is a great need to prepare an atlas of the water springs in the forest areas. Water rushes down into the streams. How to ensure that the water retention capacity of the mountain increases? Be it in the form of a glacier, or be it in the form of a water that trickles down the mountains around the year and comes out in the form of a spring. That is essential for sustaining the life there. Making an earthquake resilient building, making an infrastructure, road infrastructure that is earthquake resilient, but no drinking water, nothing to eat, no green cover, no fodder for the animal, then the life is not going to be sustainable. This is not going to be a sustainable model. So, sustainability, that is why probably the Prime Minister of India, who is a great, great visionary, he talked at every possible global forum how to save Mother Earth. Mother Earth is mother to all of us. How to do it? One more thing, so far as Indian Himalayan region is concerned, and not only the Indian Himalayan region, even the other mountain areas also concerned. See, there has been a lopsided focus on certain crops alone. Millets, which used to be a superfood, as the Prime Minister of India said. The variety of seeds in the mountain areas are largest in number. But the variety of seeds are fast depleting. Because our focus is entirely on increasing the volume of agriculture produce. Hybrid seeds. As a result, the native seeds of edibles, even the wild edibles, which is a source to many edibles, that is fast depleting. There is a need to conserve it. I know before the chair, Soumya red card, I feel extremely delighted, honored, satisfied to be associated with this huge 6th World Congress on Disaster Management. Before it is too late, it is time to address all these fundamentals. Before it is too late. Never ever. I have studied a basic science. I have a master's in physics. I served with the Defense Research and Development Organization for 4 years. I am doing a political research now, but no amount of research can completely substitute the relevance of the indigenous knowledge. Indigenous knowledge, be it about farming, be it about water conservation, be it about forest conservation, be it about any other, healthy practices, that has to be made part of, our, the declaration that emerges from Dehradun WCDM declaration. I hope I can secure this kind of assurance from Professor Durgesh, the convener of the WCDM, the chair and the co-chair of this session. And indeed, I'm sure this WCDM is going, Dehradun Declaration is going to serve long way in in creating a disaster resilience and DRR in the days to come. Thank you very much.
I just want to thank you very much. I think that was truly inspiring. And I just want to say there is hope. There's hope for all of us, all the mountain communities, mountain states, and mountain countries, when we have politicians like the Honorable MLA here. So he deserves a big, big clap. I think he didn't talk as a politician. I think he shared his wisdom with us. No, he spoke like a scientist turned into a politician, which is what we need. We need to now have politicians talking science so that we can deliver. Yes. So as a scientist turned politician, so I was correct. So that is, thank you very much, sir. That was truly powerful. And I will not be able to capture all that you have said, but you have touched on everything. And I think the commitment to the Sendai framework on disaster risk reduction itself is a huge thing. And from ICIMOD, the International Center for Integrated Mountain Development, we are committed to support the state as well as the government of India in anything that we can do to support the recommendations from this conference. Thank you very much, sir.
Thank you. Thank you so very much, sir. I take this opportunity to welcome Dr. Ranjit Sinha, the Secretary for State on Disaster Management. Sir, welcome to the Congress. Now I would like to request Professor Durgesh Pant to kindly take away from here, and distribution of a memento and shawl. I would like to request Honorable Secretary of the State to kindly grace the dais for this. And sir rightly said that we need to strike a balance between technology and economy. Sir.
See, we have this extremely rare blend of people around, because from legislation to scientists to policy makers, so we have experts from all around, all across, and Sri Munna Singh, yes, Secretary DMMC, kindly facilitate Sri Munna Singh to answer. And also to the chair, please. Dr. Pema. Yes. Thank you, Dr. Pema, for chairing the session, and ICIMOD is doing wonders, especially in this co-chair, Dr. Navneet Kumar. And Dr. Kalachan Sen, the co-chair. Please make it fast. Dr. Marcus. Dr. Marcus, please. And Dr. Rawat. Then we have from the World Bank, Dr. Malik. Dr. Meraj. Dr. Meraj. And Dr. Banerjee, please. Dr. Banerjee. And one, may I request all of you for a group picture, please. Group photograph. You be there. See, Chauhan Saab, we have been talking about economy, ecology, technology, sustainability, accountability, and from the whole world, I mean, all the experts are around. So we are extending a warm invitation to all the delegates for a gala dinner tonight, and this is from our Chief Minister's office side. So Honorable Chief Minister will be there. So you all are invited at 7 o'clock this evening. So it is from this side, right? Thank you very much, sir. Thank you. A big thank you to you all. We are starting. And I would like to thank all the delegates, all the experts, all of you, and especially Sri Munna Singh Chauhan, our chair, co-chair, all our panelists. Thank you, and a big thank you to you all for making this panel a huge, huge success. Thank you. It is indigenous. Blendways. Thank you so very much. So our next plenary starts now, and 15 minutes from now. 10 minutes break for the tea. And then this plenary is on capacity building, local to global. And the chair, Professor Surekha Dangwal, Vice Chancellor, Doon University, Professor Anil K. Gupta, co-chair Dr. Subrat Sarma from Ladakh, co-chair Mr. O.P. Singh, former DG NDRF, keynote Ms. Barbara, panelist Dr. Iftikhar K. Ahmed, Mr. Esmain Torres, Dr. Sanjay Srivastava, and Dr. Akhilesh Sojan, and Brigadier Upendra Pal Singh. So the next session starts in 10 minutes from now. Thank you. आगे हैं
प्लानरी 5 में आने वाले हैं
बस बस ठीक
मैं ग्रीन रूम में बिठाऊंगा फिर ऊपर बिठाएंगे उनको ना
ऊपर बिठा देंगे so we will have the honor of Lieutenant Governor from Andaman Nicobars in our plenary 5 also, so there he will be a chief guest.